All right, we are jumping into section 1.3, which is on conditional statements. The start thinking part says soccer tournaments like the UEFA Euro Cup are notorious for their unpredictable outcomes and nail-biting finishes. Commentators, players, and fans alike enjoy predicting scores and seeing which team will move on to the next round. Students went over and worked on this whole front page together, and then we discussed it as a class. So I will give you the rundown on what we discussed as a class. Number 1 says broadcasters often explain possible outcomes of a game. At the halftime of a match, Germany is beating England 1-0. The announcer says, if the score holds, Germany will play Denmark in the semifinal. First question was, can the announcer say with certainty that Germany will move on and play Denmark? And the answer is no, because he doesn't know what the outcome of the game is. Okay? This way that he stated it, if the score holds, then Germany will play Denmark in the semifinal. That is different than if he just said, Germany will play Denmark. That is just a statement. This type of statement that has the if in there, it's something you've probably heard a bunch of times from your parents. If you do this, then you can do that. There's a condition. You can do certain things, or certain things will happen if other things happen. So that is called a conditional statement. Reason being, there's a condition that needs to be met before the other thing will happen. So in this case, can he say for certain whether they're going to move on? No, because there's a condition that needs to be met. If no additional goals are made for the rest of the game, what will happen? Well, Germany will play Denmark in the semifinal. And the reason why is because you had a condition, and that condition was met. Now, once again, the if-then statement is called a conditional statement. The next one says, if Germany plays Denmark in the semifinal, can you say with certainty that the game ended 1-0, that the score held? And the answer is no, because Germany could have just won with a different score. Maybe they got 2-0 or 4-2 or something like that. And the special words, the fancy words to explain this, is that the conclusion does not imply the condition. Okay, so just because the conclusion happened does not mean that the exact condition was met. And we're going to be talking about this. You have if-then statements, and then sometimes you can flip those statements and you look at those as well. Number 2 says, in the group stage, each group consists of 4 countries that play each other. If the team beats their opponent, they earn 3 points. If they tie, they get 1. If they lose, they get 0. They don't earn any points. The 2 teams with the highest number of points in their group will move on to the knockout stage. So it says, on the first day of the tournament, Germany beat Portugal and Hungary tied France. How many points do each of these 4 teams have? So if Germany won, that's 3. Hungary tied France, they each get 1 and 1, and Portugal did not win, so they get 0. And once again, each team played 3 other teams, so there were 3 games on that day. The next one says, at the end of the group stage, Germany has 7 points, France has 5, Portugal has 3, and Hungary has 1. Is this enough information to figure out how many wins, draws, and losses there are? Well, you know they played 3 games. You get 3 if you win, you get 1 if you tie, and you get 0, well, 1 if you draw, if you want to use that term, and 0 if you don't win. So, yes, there was enough. Germany, the way that you can get your 7 points with the possibility of 3 points, 1 point, and 0 points would be 2 wins and 1 draw. So that would be 2 3s and 1 1. France had 1 win, which was a 3, and 2 draws. 3 and 2 come together to get the 5. Portugal had 1 win, that's a 3, and 2 losses, 0 and 0. So it's those 3 games, and it totaled out to 3. And Hungary had 1 draw and 2 losses. And we were able to figure that out using the information above about if they win, then they get this number of points. Once again, another if-then statement. The next one, if a player is chosen to play the national soccer team and they are considered to be world-class athletes, suppose you find out that a world-class athlete is coming to your town, can you assume that they are part of the national soccer team? Why or why not? No, you cannot, because you don't know that they play soccer. Okay? And then the last one is come up with your own sentence in if-then form, a conditional statement. So if you say, if I play the drums, then I'm a musician. Okay? So these if-then statements have truth values. You can come up with if-then statements that are true or false. So in this case, if you play the drums, you're a musician, that one would be true. Now we can flip it so that the thing that came first now comes second and second comes first. You could say, if I'm a musician, then I play the drums. And in that case, that is false. So it is not true in reverse. And we're going to come up with a name if it is true in both ways. So let's move on to the quick notes. The quick notes are basically summarizing what we learned and actually putting names to it. So the if-then statements, there's a special name for that. It's called a conditional statement. A conditional statement is if A, then B. The A part, whatever comes first, you could say is the condition or the hypothesis, and the B is going to be your conclusion. Now, if you flip it so that what came first goes second, that is called the converse, okay? Just because the original is true doesn't mean the other one's going to be true. If the original is false, that does not mean the other one's going to be false. The converse is going to be false. In the case where both of them are true, then we call that a biconditional, okay? And you could see the symbol that we use there, and you could put it into words, A, if and only if B. So let's say you said, if I pass geometry, then I will move on to algebra 2. And if I go on to algebra 2, then I must have passed geometry. Since both of those are true, we can write that as a biconditional. And we could say, I will move on to algebra 2 if and only if I have passed geometry. Now, the students then went over and did their check their understanding part. It says, look at the two sentences below. Which of the two sentences is true? How do you know this? So it says, if something has stripes, then it's a zebra. And if it's a zebra, then it has stripes. It's going to be the second one. If it's a zebra, then it has stripes. But there are many things that have stripes that are not zebras. I actually had a student in my class that had hair that had hair that had stripes in it, like dyed stripes. So the second would be the only one because all zebras have stripes. Not all striped animals are zebras. The next one, decide if the statement is true or false. If it's false, give a counterexample. If you have 25 cents, then you have 2 dimes and a nickel. That is false. It could just be 25 pennies or a quarter. We could go over and try to look at the converse. If I have 2 dimes and a nickel, then I have 25 cents. That is correct. So the original statement was false, but the converse was true. The next one, if a number is divisible by 4, then it's divisible by 2. That's true. If you do the converse, if it's divisible by 2, then it's divisible by 4. That's false. So since one is true and one is false, you cannot write that as a biconditional. If a figure is a rectangle, then it has 4 sides. That's true. Let's look at the converse. If it has 4 sides, then it's a rectangle. That is false. And since both are not true, it is not going to be a biconditional. The next one says, consider the statement, if your body temperature is 103, then you have a fever. Identify the condition and the conclusion. Your body temperature is 103 would be your condition, and you have a fever is the conclusion. The converse of this would be, if you have a fever, then your body temperature is 103. That is false because it could be 104 or 105. Next, if a soccer game in the knockout round ends in a draw at the end of the 90 minutes, the game continues into overtime. Is this a biconditional? I got mixed answers when I was talking to students about this. I said yes and the key said yes, because the only way that you would go to overtime would be if it was a tie or a draw. But a student was mentioning that if there's penalties or something like that, you will go further. Some kids said that's not technically overtime, that's just extra minutes put on. I don't know enough about sports to be able to answer that correctly. But they say yes, and if it was, then you could state you will go into overtime if and only if there is a tie, or there is a tie if and only if you go into overtime. You could write it like that if it's a biconditional. Let's go ahead and take a look over the homework. On the first one, it says use the options below to answer the question. Option A is it is going to rain. Option B is if it rains, then there are clouds. Which of the following is a conditional statement? It's got to be B, because there is that condition that if it rains, that is the condition, and the conclusion would be then there'd be clouds. There's the if then, so it's B. What are the condition, hypothesis, and the conclusion? The condition is it rains. Conclusion is there are clouds. What is the converse of the conditional statement? Is it true? If not, give a counterexample. If there are clouds, then it's raining. Then it will rain. That is going to be the converse, but that is not true. So we can't write this thing as a biconditional. The next one says, look at the 2 sentences below. If you flip a quarter, then you'll get heads or tails. If you get heads or tails, then you flip a quarter. Which of the two statements is true, if any? It would be the first one would be true. The second one is false. You could flip a penny and get heads or tails. Number 3, in parts A through C, determine if each statement could be written as a biconditional statement. If so, write the statement as biconditional. If it is Christmas Day, then the date on the calendar is the 25th. That's true. If it's the 25th, it's Christmas Day. That's true. So we're going to say this is true, and it's going to basically be a biconditional. And you could say it is Christmas Day if and only if it is 12:25. If you're a chef, then you know how to prepare food. That should be true. If you know how to prepare food, then you're a chef. That's false. So since they're not both true, then that is not going to be a biconditional. Some people would say, no, if you can prepare food, then you should be called a chef. But you're not like a formal chef. If someone lives in the northern hemisphere, then they are above the equator. True. If they live above the equator, then they are in the northern hemisphere. True. Therefore, you can write it as a person lives in the northern hemisphere if and only if they live above the equator. What do you notice about all the conditional statements that can be written as biconditionals? It seems like they're all based off of some kind of definitions, or they're just saying the same thing in two different ways. Okay. The next one that you guys were supposed to do was number 4. The first 6 shapes of a repeating pattern are shown here. Decide whether the statement is true or false. If it's false, give the counterexample. So in the first one, if the previous shape is a circle, then the next shape is going to be a diamond. Take a look, and every single one where the previous one was a circle, the next one will be a diamond, so that's true. If the previous shape was a diamond, then the next shape would be a circle. If you look from 4 to 5, the previous one was a diamond, and the next one is not a circle. So that would be your counterexample. Now, the next ones, you are considering the conditional statement. If Michelle gets out of work by 5 p.m., she'll stop at the grocery store on the way home. Determine if the following supports that, contradicts that, or is just flat out unrelated. So the first one would be Michelle got out of work at 4:50 and got groceries at Kroger. That supports it, goes along with what they were saying. Michelle got out at 4:45 and got gas for a car. That doesn't really have anything to do with anything with the conditional statement, so unrelated. Michelle went to the grocery store on Saturday. That has nothing to do with this. It's unrelated. We're not talking about work days. Michelle got out at 4:30 and did not stop for groceries. That contradicts it. So it met the condition, but it didn't satisfy the conclusion. Michelle got out of work at 5:30 and got groceries. That one would be unrelated because it's not within the time frame they were talking about. And the next one is Michelle did not get groceries on her way home, so she must have not gotten out of work at 5 p.m. That supports it. If she got out before 5, then she would have gotten groceries. And the last one is saying you have a triangle that is right and it has sides ABC. Jenna found out that the area of the triangle is 1/2 AB. Complete the conditional statement. If it was a right triangle with sides A, B, and C, and the formula is 1/2 AB for the area, not the formula, but that's what the area is, what must be true? Well, A and B had to be the base and the height. You would have a base and a height. If A or B were the hypotenuse, that wouldn't have worked. So a different way you could say is neither A nor B are the hypotenuse. All right, hopefully that made sense. Thanks for watching.